Okay, I know that it has the 5 terms right here on number 1, kind of like on the quiz. I gave you kind of a word bank that you could use. If they're, I can't remember if it's on the test, but if it's not on the test, I'll put them up here for tomorrow. So you don't necessarily have to memorize the words. You just have to know and identify which one's which. And I'll put that up there for spelling purposes too. On this one here, you have 5 different pieces. All 5 of them are going to be different. So you're going to use all 5 words. You just have to identify which one's which. Okay, the rest of this page I think is pretty straightforward. Finding x, finding some arc measures. Number 4, let's take a look at that one real quick. This one was probably the most missed problem on the quiz, okay? Because when I look at this segment right here, 8 is only the outside part, okay? A lot of people were trying to say that this whole thing was 8, because that wouldn't make sense, because if this is a right triangle, this can't be smaller than this, right? This side has to be bigger than 12. So what you had to be able to identify here is that this is the radius right here. If that's the radius, then any segment from the center to the edge of the circle is also the radius. So this little piece here would be 12 because it's also the radius. And then what that helps me with is this whole thing is 20, 12 plus 8. Okay, that was the one that was probably missed the most on the quiz. I kind of like, you probably don't necessarily have to do this part, but I think it helps to just draw out the right triangle, label the pieces of the right triangle, and then what am I going to have to do to find x here? Pythagorean theorem, okay? And so Pythagorean theorem is not a formula that we're giving you, so don't put it on your formula sheet, but we've done it enough, you should know. A squared plus b squared equals c squared. Okay, 5 and 6 aren't too bad. I don't think much to talk about there. The biggest thing, and I told you this on the quiz too, really pay attention to the directions, both on the review and on the test tomorrow. Is it asking me to find x? Is it asking me to find a length? What are we trying to find? Okay, so really pay attention to what you're looking for. 7 and 8, I don't think there's too much to those. I'm going to go down here. 9 and 10 are basically the same problem. Now, as I look at 9 and 10, the radius is what we're looking for. So, is the radius drawn on anywhere on this circle, if I did number 9? Because what does the radius connect? End of the circle to the center, okay? And so like if I did QA right here, A doesn't go all the way to the edge of the circle. Same thing here, Q to B doesn't go all the way to the edge. Q doesn't connect to any other segments, right? So what we have to do here is we have to draw in a radius. And there's a lot of different radii that you could draw in here. There's really no particular one you have to draw in, but you have to connect Q to the edge of the circle. So I could go Q to F, I could go Q to G, I could even go Q to E and Q to H. There's 4 different radii I could draw in there. You don't have to do all 4 of them. Really just one of them is sufficient. And then you're going to pick out one of the triangles. I'm going to use this triangle right here. And I'm going to label it. I do think that it helps to kind of label. Q is the center, then A, and then F. Okay, we know that EF is 16. When the arrow points at EF, that means it's the entire thing. It's pointing to the middle, okay? And what does QA do to segment EF? Cuts it in half. It's perpendicular, but it also bisects it. It cuts it in half. So that means each one of those pieces is 8. So AF is 8. 16 divided by 2. Okay, the other piece here, AQ and QB, are both labeled 4x plus 3 and 7x minus 6. Because those both bisect and perpendicular to those segments, we know those two are congruent. So I can set 4x plus 3 equal to 7x minus 6. And then we're going to solve for x. Okay, I'm going to let you kind of do that part. Get x. Once we solve for x, once again, it doesn't say find x. Don't stop there. That's what some people did on the quiz, is they stopped right there. But we don't want to stop there, because I'm going to take that number, plug it back in for x, and find out what the length of AQ is. And that's what I'm going to put right here. And then QF is your radius. And that's what we're solving for. Okay. So then once again, you'll have to do the Pythagorean theorem. You're going to use the Pythagorean theorem a lot on the test tomorrow. Okay? It's something we're going to use over and over and over again. Okay, number 10 is basically the same thing, just different numbers, a little bit different picture. All right, if you would get out your formula sheets, I want to make sure you understand how to use the formula sheet, especially because I was gone on Thursday and Friday. I'm just going to kind of go through this stuff. If you have questions, ask, and we can go over anything that you have questions on, especially since I was gone. Okay, it's asking me to find angle A. So I'm going to go to the top of my formula sheet, right? Angles. We're trying to find an angle. So I know that I'm using angles. I'm going to use one of those formulas. So you're always going to go to the middle. Right here, it says, where is the vertex? So that's where I start off at. You always start in the middle. Well, the vertex is where the two segments meet. They meet at A. A is what we call the vertex of that angle. It's in the middle. You have three options. It can be inside, outside, or on. Okay? So where would A fall in this picture? On. Okay? In this, it is on the circle. Sometimes it's inside, sometimes it's outside. And we'll see examples of each one of those. When it's on, I'm going to go down here. On, what's the formula when the angle is on the circle? Arc divided by 2. We know the arc is 84. So we just got to take 84 divided by 2. Okay. If I already give you the angle, we're still using the same formula, but make sure you know how to use the formula. If I already give you the angle to get to the arc, what are we going to have to do? Yeah, we're just going to have to go the opposite direction, right? So pay attention to whether you're given the angle or the arc, and you're either going to divide by 2 or multiply by 2. Okay? And what I'll tell you on some of these problems, the math is not hard. It's not hard to divide by 2 or multiply by 2, right? We just have to understand how and why. What formula are we using, and knowing when to use it. Okay, this is not on your formula sheet, okay? So this is not something to add. This is something you just have to know. When we have a quadrilateral inside of a circle, then we have 4 angles that are made here, okay? 1, 2, 3, 4. Opposite angles have a relationship. What is the relationship between angle E and angle G? They're supplementary, okay? So we know that Q would equal 180 minus 80. So Q would be 100. Okay? D would be 80 because opposite angles are supplementary. So I can set 4R equal to 80, and then I could solve for R. Okay? The equations that we have to solve here aren't overly difficult. It's just a matter of knowing the rules and how to do it. 14. Once again, we have an angle here, okay? We want to find the value of that angle. We know it's an angle because it's got a little degree symbol up there by it. These two arcs are not the same. So that means X is not at the center. Okay, so it's not 128, it's not 94. It is inside the circle, but not at the center. So when you look at that and want to know, is it at the center or not? If these two numbers are not the same, then it's definitely not at the center. That's the easiest way to tell. Okay, so we look at our formula sheet. It's inside, but not at the center. So we're going to add those up. Divide by 2. The one thing I told you last week when you do this is you got to make sure you put parentheses around it or hit equals before you divide by 2. Depends on your calculator. But if you don't do that, one or the other, it'll probably give you a different answer, depending on your calculator. Okay, 15, a little bit tricky here. X is outside the circle. The two segments meet outside the circle. So here's the third formula. Okay, inside, outside, and on. We already did one that was on. We did one that's inside. This is outside. We know the big arc because it's given to us, 250. What would be the measure of the small arc? How much? 110. How'd you get it, Charlie? 360 minus 250. Okay, so that'd be 110. Those two arcs together, as long as those two segments are tangent, those two arcs together have to add up to be 360. Because the angle is on the outside of the circle, the only difference here is we would subtract and then divide by 2. And that would give me x. Once again, I would probably make sure you put it in parentheses, just to be careful there. Okay, 17. Another thing to keep in mind here, K and L are both tangent because you got the radius connected to a tangent. So those are both 90-degree angles. How many degrees are there in a four-sided figure? 360. Okay, so you can use that fact to help you there. All right, here is where we are starting segments. The reason or how you know the difference is we're trying to find the length of this segment. There's no degree symbol next to it, right? So now we know we're doing segments instead of angles. So now we're going to go to the bottom of our formula sheet, and we're going to use some of those formulas for segments. Once again, when the segments intersect, do they intersect inside or outside of the circle? Okay? And that's the question you're asking yourself again. Outside or inside? These obviously intersect inside. Okay? And because I was gone on Thursday, I just want to make sure you guys are perfectly clear here on what to do here. It really doesn't matter, bless you. These two could be AB, these two could be CD, but A and B have to be the two segments or two pieces of the segments that are on the same segment. Same thing for C and D. So I could label these two A and B and these two C and D or vice versa. Okay? A couple of different ways that you could go about it. But the formula is A times B equals C times D. So I'm going to do 10 times 18 because those are the two pieces on the same segment equals. Now here's the part you got to be really careful of. I got to take 9 times x minus 3. And when I take 9 times x minus 3, I got to make sure that I put x minus 3 in parentheses. If you don't put it in parentheses, then you're going to forget to do what? What are we going to have to do here with 9? You got to distribute it, okay? If I just wrote this, most of you are going to forget to distribute, right? Because we don't see parentheses there, so we're like, oh, we don't need to distribute. But when I see parentheses, that's usually the indicator that we got to distribute the 9 throughout. Once again, we've solved problems like that for several years now, right? I don't think the solving part is the hard part. Setting it up, knowing the rule, and how to apply it is the hard part. The math tomorrow should not be the difficult part. Okay, on this one here, the two segments meet outside the circle. So once again, we're finding the length of a segment, okay? In this case, we're trying to find the length of the inside piece. We have two secants that go through the circle, okay? You have basically two different kinds. Whenever the segments meet outside of the circle, either you're going to have two secants, like this one here, or you're going to have a secant and a tangent. I'm going to do one of each with you, just because I was gone last week, and make sure you guys understand what's going on here. All right, so for this one here, we take the entire length. The length of that entire piece is 16 times the outside piece. 16 times 6. Outside times the total. For the other segment, the whole piece is x plus 8. You have to write x plus 8. Is it okay if I write 8x? No, because that means multiply. 8 times x and 8 plus x are not the same thing. 8 plus 2 is 10. 8 times 2 is 16, right? Two completely different operations. So you got to write it as x plus 8. So we're going to take the outside times the total, the whole thing. Once again, parentheses is a really, really big deal here. I can't stress it enough. If you don't put it in parentheses, you're probably going to miss this problem, okay? Because when I see parentheses, I know I got to distribute, and then I got to solve for x. Okay, I will give you a hint here. Number 20 is the one where you have to do factoring. Okay, so I'm going to let you work through this one. If you need some help with it, this is why we reviewed factoring last week, because you have a problem here where you have to do factoring. Okay, and we did some problems like that on Thursday when we did that. If you need some help with it, let me know. We're trying to find the length of x. I did not post the answers to the factoring page yet. I'll do that today too. I'm not going to take that for a grade because that was just some kind of practice review stuff. But that way, if you want to check those, I'll post that tonight. I never did get that posted last week before I left. Okay, 21 and 22 are both very similar. The difference here is that we have a tangent and a secant. Okay, we know this is a tangent because it's not going through the circle. It intersects or touches the circle at one point, W. Okay, when you have one that goes through the circle, that part we're going to do just like what we did on the last one. 8 times x plus 8. X plus 8 is the length of the whole thing, multiplied by the outside. The tangent doesn't have an inside and an outside part. So the tangent is always tangent squared. Once again, make sure you put parentheses, and then you can solve it out. Okay, and I'm just kind of helping you get these set up. Obviously, they still need solved. I'm just trying to get it there for you. Okay, 23, 24, 25. This is where you're going to use this equation of a circle formula. Okay. 23 and 24 are pretty straightforward. Those are the center and the radius is already given to you. Let's do 24, actually. X minus 10 squared. Notice that it's always going to be the opposite. Plus y minus negative 7 is y plus 7 squared. So the signs are always opposite, right? That's where you got to be really careful. And then here, we're going to take the radius and square it because it says r squared. So we're going to take 3.5, square it, and that would become 12.25. Okay. Don't leave it as 3.5 squared. Just go ahead and put it in your calculator and give me whatever 3.5 squared is. All right. On 25, there's two ways to do this one. Okay. If I have a circle, and I want to find the length of the radius, if I don't know the radius, then I can find the distance between the center and the edge. We know that's called the radius, and in order to get that radius, we could do the distance. I shouldn't put D there because that might confuse you and think that it's diameter. D is like the distance between 2 points. Okay? So, one way you could do this, and this is not one of the formulas that you're going to be given, so this may not be the method that you want to use, but if you remember the distance formula, then you can do the distance formula here. Okay? So that's one way. I'm not going to go through it that way because we've done the distance formula quite a bit. I'm going to show you an alternate route to go here. I'm going to write the equation of a circle up here. The center is always H and K. So the center is your HK. Your radius, your point on your circle to get to that is your X and Y. It could be any point, okay? So the center is always H and K. The other point that you're given is just a random point. We call that one X and Y. So we know X, H, Y, and K. We don't know R. So we're trying to find out what R is. It doesn't ever give me the value of R. So we're going to plug those four numbers into our formula. -4 minus -1, which is really -4 plus 1. 2 minus 2 squared equals R squared. So we have one unknown. We have R. We don't know what R is. Now it's just a matter of doing some math. Okay? -4 plus 1 would be -3. -3 squared is 9. 2 minus 2 is 0. 0 squared is 0. Okay, and this is really what we want. You could solve it and you could say R is 3. But when we put it into the formula, we really want the R squared value. Okay? So that's where you got to kind of be careful. Now you're going to plug it back into this. When you plug it back in, you don't put these two numbers back in. You put in H, K, and R squared. Kind of like we did on number 24. So all we really do is use these two to find what the radius is. If you want to do the distance formula, you could do that, and you'd get the same answer. Okay, questions so far? Okay, if you have questions on big ideas, I looked last night, big ideas, a little disappointed how much big ideas were done last night when I looked. You guys had all week last week to do all of those assignments, and there were some that haven't even been touched. And so that makes me wonder what we were doing when I was gone on Thursday and Friday. So make sure those, you got 4 of them that are due tomorrow. 4, 5, 6, and 7 from chapter 10. The factoring is not for a grade. That was out of the book. I'll post these answers tonight. They'll be up for you to check. I'll post the factoring answers so you can check that tonight if you want to make sure you're doing those correct. I'll come around and help you today. If you want to come in tomorrow morning,